an equation for a rational function when given certain characteristics. And say we're given that we have a vertical asymptote at x equals 4/5, a horizontal asymptote at y equals 2/3, and an x-intercept at -5, 0. So what do? They want us to find an equation for a rational function. First, I would recommend surveying the information. And this horizontal asymptote is going to tell you something. First of all, since it's not equaling 0, then you know that the degree of your numerator and your denominator are going to be the same. As in, for simplicity's sake, let's say it's x over x. And you could really do x squared over x squared, x cubed over x cubed. You could do a lot of different, create a lot of different numerators and denominators and a lot of different rational functions. But for simplicity, let's just do a degree of 1. Okay. And what is the horizontal asymptote? Well, it's the ratio of the leading coefficients of your numerator and your denominator. So it's 2/3. Okay. So next, we need to deal with a vertical asymptote and an x-intercept. Let's go ahead and deal with the vertical asymptote. So, generally, when we're finding a vertical asymptote, where does that information come from? The numerator or the denominator? Well, it comes from the denominator. And we can sort of reverse the process of how we find a vertical asymptote. So we know that we can't have 0 in the denominator. So that's how we normally set up finding the vertical asymptote, is we set a denominator equal to 0 and then solve for x. So here, what you can do is you have x equals 4/5. So generally we start by setting 0 equal to 1 on one side of the equation. But here we're going to end up with 0 on one side of the equation by manipulating things around. So x minus 4/5 equals 0. So we can plug this in the denominator, but where exactly and how exactly? Oh, it's important to put these parentheses around so that your proportions stay the same. And you'll see that also if you think about this as putting your denominator equal to 0, then this 3, when you divide by 3 on both sides, it's going to go away, and 0 divided by 3 is just going to be 0. So you will end up with x equals 4/5 as your denominator when you make sure to put your parentheses around your x minus 4/5 when putting it back in. Okay, so next we have to deal with an x-intercept. So where do we look for our x-intercept? Well, we set y equal to 0, and the numerator in particular comes into play. So you have a -5. So we already know x is -5 when y is 0. But we need to factor in, to think about having some unknown, we'll call it b, equaling, and then this 2 times -5 plus b will equal 0. So what is b? It's going to go right here, and we can solve it. -10 plus b, so you get b equals 10. So plus 10. Okay, well, since I'm grading this, this will work out as a correct final answer. If you're given multiple choice, you might want to clean it up a little bit by distributing the 3 and then getting rid of a fraction. It's sort of unconventional to have a fraction in the denominator, okay, or in the numerator, so that you have multiple fractions going on. So to get rid of that, you could do 5 over 5 and multiply that by your equation for a rational function. And